Welcome back everyone to our next lesson. Right here we are going to be talking about main planes or wings. The wings or main planes generate lift and in steady flight will support the weight of the aircraft in the air. When the aircraft is maneuvering, the wings will have to support loads which are several times the weight of the aircraft. So therefore the wings must have sufficient strength and stiffness in order to be able to do this. Okay, the degree of strength and stiffness is determined by the thickness of the wing, with the thickness and the type of construction used being dependent on the speed requirements of the aircraft. Okay, the various types of wing construction are biplane, braced monoplane, and cantilever monoplane. Okay, we are going to go through these three types one by one. Let us start with the biplane construction. You will see an example right here. So very few biplanes fly at more than 200 knots in level flight, so the air loads are low, which means that a truss type design, hopefully you remember that from the previous lesson, so a truss type design which is covered in fabric is usually satisfactory here. The wing spars, interplane struts and bracing wires form a lattice girder of great rigidity, which is highly resistant to bending and twisting. Now, unfortunately, these struts and bracing wires will also generate a relatively large amount of drag, which accounts for the modest speed of biplanes. Okay, so rigidity, but the price of that is the increased drag. Okay, moving on to braced monoplanes. This design is also used on low-speed aircraft. In the braced monoplane, the wings are strengthened or braced, hence the name, by external struts which help relieve the bending loads applied to the wing spars in flights. Okay, so you see one example here. This is a very famous braced monoplane, the Spirit of St. Louis, in which Charles Lindbergh piloted in his epic solo flight over the Atlantic. Okay, so that was braced monoplanes. Let's move on to the cantilever monoplanes. On a cantilever monoplane, the wings are unbraced and they are supported at one end only. Okay, so most modern aircraft are cantilever monoplanes. Cantilever wings have to absorb the stresses due to lift and drag in flight and their own weight when on the ground. Okay, now quick look at the construction of the cantilever wing. The load-bearing ability of a cantilever wing is achieved by building the wing around one or more main load-bearing members known as spars. Okay, these spars are constructed so that they will absorb the downwards bending stresses when on the ground and the upwards, rearwards and twisting stresses when in flight. Okay, the major structural components of the cantilever wing are generally manufactured from aluminium alloys with composite materials such as glass reinforced plastic, carbon reinforced plastic and honeycomb structures being used for fairings, control surfaces and flaps, etc. The relief of bending stress is aided by positioning the major fuel tanks within the wings as well in some types of aircraft. So cantilever wings may be of single spar, twin spar or multi-spar construction. Self-explanatory really, so depending on whether there's only one spar or more than one spars being used in the wings. The conventional main plane structure would consist of front and rear spars with a metal skin attached to the spar boobs to form a torsion box which counteracts all the twisting forces. Okay, now the skin of the cantilever wing helps to bear the loads as well, and it generates direct stresses in a span-wise direction as a response to bending moments and also resists twisting here as well. The stringers are also span-wise members, which will give the wing rigidity by stiffening the skin in compression. And you will also see the ribs here. The ribs maintain the aerofoil shape of the wings, and they support the spars, stringers and skin against buckling. Okay, and they also pass concentrated loads from the engines, the landing gear and control surfaces into the skin and the spars. All right, so much about the construction of the cantilever wing. Let's have a look at a quick quiz now. A couple of questions. Choose the correct answers as a quick review of our topic today. This image shows an example of biplane, brace monoplane or cantilever monoplane. 3, 2, 1. Hopefully you've all chosen cantilever monoplane, which was the correct answer right here. Okay, moving on to our next question here. What do you see in this picture right here? Wing spars, interplane struts, bracing wires, or bracing wires, all right. Hopefully you've chosen the interplane struts right here. Interplane struts is the correct answer. Right, moving on. Another example. Here, is it an example of biplane construction, brace monoplane or cantilever monoplane? In 3, 2, 1. Hopefully you've all chosen the biplane construction right here. Next up, what does this image show? Wing spar or wing spars, interplane struts or bracing wires? In 3, 2, 1, the correct answer is wing spar, singular. In this case, we are looking at only one example of a wing spar. All right, next up here, the image shows an example of biplane, brace monoplane or cantilever monoplane. This will be a braced monoplane. Hopefully you've all chosen that as the correct answer. All right, and I think we've got one more question right here. What does this image show here? Wing spars, interplane struts or bracing wires? Hopefully you have all chosen the bracing wires here. So bracing wires is the correct answer here. And that's it for today. If you have any questions, suggestions, please let me know in the comments. If you feel that this short session was useful and you've learned something, there is something that you have taken away from this session right here, then a like or a click on the subscribe button will be much appreciated. Thank you very much for your attention, and I'll see you again in the next one. Goodbye everyone. Take care.